So from our notes, this is where the programs are. I updated our notes yesterday to include a little bit about the break statement and the continue statement. So let's just step through these programs briefly, and I'm happy to talk through any questions or anything. Oh, hi, welcome Evan, come on in, good morning. So our notes, they go section by section, but the part that is new is this part here, section 4.8. So we have the definitions of the break and continue statements, their functions. The break statement causes immediate exit from that loop or statement. And we saw the break statement before. Does anyone remember what context we saw break statements in before?
Switch case.
Yeah. Switch cases, exactly, yeah. In each of our cases in a switch statement, we would have a break statements. And those would end that particular, case, that sub-expression, and then we would move on to then we would prevent moving on to the next case, or we would prevent following through by using the break statement. So the break statement causes the loop or statement that's currently running to end just right then and there. The continue statement, which we'll see in the second program, causes the loop that is currently running to skip all of the remaining parts of the body of the loop, all the remaining statements in it, and instead just start with the next repetition. So the continue statement causes the currently executing iteration of a loop to terminate, and the next iteration then begins. So let's take a look at these programs. One is called break statements, and as we can see, it just has the package and import statements and the class heading and the main method heading. Okay, kind of boring. But then it gets a little more interesting. We set up a scanner object and a num variable that's an int, or an int variable called num. And then here's a while loop where the condition is just true. So that might make some people nervous, right? Because it could, it'd be easy to make the mistake of having this be an infinite loop if the condition is just true, because true is always true. So we need a way to break out of that statement, or else we'll have an infinite loop. And the idea is, in the loop, we'll prompt for a number between 1 and 100, and then read in a number, store it to that num variable from earlier. And here's our condition where we break out of the loop. If num is between 1 and 100 inclusive, then we'll exit the loop with this break statement. So I'll just paste in the code from the nodes. I'll change the package declaration to match the name of the package that I just made up right now, break statements. And then let's see, source format to make it to make it easier to read. And then, oh, this is interesting. Let's see if we can fix this error. Break outside switch or loop. So, oh, when I copied it, things got all mixed up. Actually, this could be a good exercise if we hadn't just seen it. But the while belongs right before the prompt. Oh, sorry. And then let's do source format again and see if this makes any more sense. So does this look like the program from our notes? Yeah. Okay, cool, awesome. Okay, so let's run it and let's see. Let's try out, maybe we can pick 3 test values and have the first 2 be outside the range and the last one be in the range. So the range is from 1 to 100 inclusive. How can we test this out? Let's pick a value that's outside the range first. 0, okay, that's an awesome test case, by the way, because it's close to one of the upper or lower bounds. Nice. And it looks like we get the expected behavior of the loop continuing. We don't break out of the loop because the if statement only led to the break statement if num was between 1 and 100. So let's try one more. Any number that we can test and make the loop keep running. 200, okay. Okay. And now how about an example where we can reach the break statement?
36.
36, does everyone agree with that answer? Yeah, okay, cool. Yeah, I think you're right. Awesome, so 36, a number in that range reaches the break statement, and so we exit the loop. We also have a program in this section, 4.8, break and continue statements for the continue statement. The idea with this program is once we get into the main method, there's a for loop with a counter variable I. It's an int that goes from 1, and it doesn't quite go to 100, but it's less than 100. So the last value it'll take on is 100, and that's when the loop will end. But what's happening during this loop is I is going from 1 to 2 to 3 to 4 to 5 all the way up to 99. Well, we're testing whether when I is divided by 3, the remainder isn't 0. So what would that mean about I if when we divide it by 3, we get some positive remainder? Yeah.
It's not a multiple of 3.
It's not a multiple of 3, yeah, exactly, awesome, yeah. And can you remind us what is a multiple?
If you take a number and then divide it by like 3 in this case, it would have a remainder of 0.
Yeah, exactly,
So it's like an integer.
It's like
It's an integer, not like a decimal.
Yeah, awesome, cool. So yeah, the multiples of 3 are all the numbers that can be divided by 3 with no remainder. Yeah. So let's, so in this program, when we find out that something's not a multiple of 3, then we continue, meaning we just start the loop again without proceeding to the other statements in the loop. So it's kind of like a reset button. Okay, so let's run this. Wow, this one got messed up too. So there's our program, and let's go ahead and run it. And it looks like we only reached that statement where we print out I when the remainder when we divide by 3 is 0. Yeah, so when we have a multiple of 3. So some applications of the break and continue statements. Okay, any questions about that? Okay, cool, thanks. All right, that's everything. Yeah.